Thank you, Pat. It's a pleasure to be here. I thought in the introduction, I told him that I was in the top 10 of my high school class in graduation. And he missed that. Must have found out there were only 10 in my class, I suppose. Well, you know, as we look at where we are today, I think it's safe to say that the need for natural resource conservation has never been greater. The world population is growing at a relatively rapid pace yet, and the need for space for buildings and for food and fiber is ever increasing. Now, I remember when I was a youngster, and then, I'll say about 9 years old, I can still remember that far back, the world population was 2.5 billion. And the U.S. population was about 151 million. Today, the world population is over 7 billion, and it's adding about 75 million per year. And the U.S. population is set at about 313 million, and we're adding a new person every 15 seconds. And all of this then amounts to added pressure on our natural resources. In Minnesota, and in other parts of the country as well, but in Minnesota, due to agricultural economics, crops, row crops particularly, have increased in acreage, while small grains, pasture, have decreased. And this has resulted in greater erosion and nutrient loss potential. And on top of that, we now see the likelihood of losing significant acres of CRP. Then, in my area, which is the Red River Valley, we are adding miles and miles of drain tile without ever really knowing the hydrologic or water quality consequences. So this is not a pretty picture for those of you who are tasked with improving natural resource management and water quality. The need to identify and evaluate potential natural resource project sites is paramount. This has typically been a lengthy, expensive process. Usually it has meant on-the-ground data collection. The conditions in order to collect this information had to be right so that the crews could gather the needed information. Probably, most of you out here know that a whole lot better than I do. It's been in the past accomplished by lots of labor-intensive surveying. More recently, some other newer technologies, such as GPS and GIS, have made data gathering easier and more accurate. And for someone like me, who thought the development of the mechanical pencil was a marvel, these have been truly life-transforming. Now here's a cartoon that sort of expresses my feelings as I consider LIDAR to be a miracle technology in our work. LIDAR is truly a technology that is transforming the gathering of landscape data. And when LIDAR data is coupled with GPS and GIS, we have an extremely powerful way to examine our landscape. And I think the information that was shared to us by Dr. Mulla points that out very, very adequately. But this coupling of LIDAR with GPS and GIS has added a new dimension to our ability to identify, plan, and target conservation projects. And this is a technology which is available to you right now. If you've not used the products of LIDAR, you're missing some real opportunities. When the 1997 flood devastated much of the Red River Valley, it precipitated an evaluation of the way the valley watershed districts were approaching flood prevention. We had a process that happened right after that. I'm not going to go into the details, but after that long mediation process, it ended in the result that as we sat down with the DNR and other state agencies and federal agencies, we ended up adopting a plan that laid out how we were going to henceforth plan and build flood retention projects that incorporated natural resource benefits. In order to accomplish this mediation plan, it called for the formation of watershed district project teams. Now, these project teams are composed of personnel from state and federal agencies, environmental organizations, landowners, and anyone else who might be a stakeholder. The idea is that if all the players are together to evaluate the options and agree upon a particular option, then getting the necessary permits is largely a formality. Everyone has been at the table, they've been able to have their input, and we assume then that all the agencies are on board. And they've been able to shape the project the way they think, it ought to be. Now, concurrent with this development of the mediation process and these project teams, concurrent with this was the development of a research and education institute that eventually became known after several iterations as the International Water Institute that was mentioned just a moment ago. Anyhow, one of the first things that the IWI did was to meet with the many water management organizations in the Red River Valley, and there are many of them, not only in the United States, but we also worked with those that were in Canada. And we asked these people, what is your greatest need as far as accomplishing flood damage reduction? What do you need that would be the most help to you in designing projects and working on these? And the overwhelming response was the need for an accurate digital elevation model. Well, it took quite a while, it seemed like anyway, but the IWI, under the directorship of Charles Fritz, did accomplish this goal. LIDAR data that was needed for this was collected from about 2007 to 2010, and it has resulted in the digital elevation model that has become so valuable to our water management and natural resource planning in the Red River Valley. Now, one value-added product that is an outgrowth of this digital elevation model is the what's called the LIDAR viewer. And you can go to, I got to look at this and see if this is the right place. You can go to the it doesn't look like the right slide, but you can go to the IWI website, or perhaps even more accurately, you could go to the RRBDIN, which stands for Red River Basin Decision Information Network.org, just rrbdin.org, and you can find this LIDAR viewer there. I urge you to do that because it's quite entertaining and very useful. Now, this same kind of viewer is also being developed for the rest of the state by the DNR, And if you go to the Minnesota DNR Data Deli, and I thought I had a slide that had all of these on there. At any rate, if you go to that, you can see that LiDAR viewer, and it's a product that I think is really very helpful. And I wanted to mention that you could also go to the University of Minnesota Water Resources Center website that also has some very good information about LiDAR, as well as workshops, schedules of workshops that are coming up. What I want to do next is to show you some actual projects that have been built or are in the process or planning stages where LiDAR products, such as the DEM that we have, are of tremendous value. Now, flooding is a primary concern in the Red River Valley. And this is a view of an urban township addition that we have called Oakport. This area is an area that sustained heavy damage in the floods of 2007 and 2009. This picture that you see was taken during the 2011 flood, when there was no damage due to flood protection, a project that was undertaken by the Buffalo Red River Watershed District that is now nearly complete. And if you can look on here, you can see the dikes that have been built around here, and some that you can't see too around here and here. Anyway, and all of this is Oakport. There's a big kind of a slough that runs through here that we kept open in order for the river to run through here as well, the floodwater. So, you know, if we'd have diked that off, it would have raised the water level on the river, and we weren't allowed to do that. So, but the dikes that were built with the aid of LiDAR data that really helped in doing that. Now, this project isn't complete. It's nearly complete. There's about $6 million work left to finish the project. And I might ask if there are any legislators present. I don't suppose there are. But if there are, and if they see this, I would request that you seriously consider a bonding bill that will provide for the completion of this project. I have a bag that I'm willing to take back if I could get it. Anyhow, you know, LiDAR is extremely helpful to this project. Now, another project that we have completed is a multi-purpose project on a small stream, really, that it's a tributary to the Buffalo River. It's called Whiskey Creek. And this project is comprised of 6 components. Early in the process of planning this by the project team, it was recognized that there was a need not only to store water, but to undertake other actions to more holistically treat the problems of this sub-watershed. So we have setback levees to prevent breakouts in places. We have diking in some areas. There's some 800 acres of WRP wetland restorations. Buffer strips have been added in places, and there's an impoundment that will store up to about a little over 1.6 inches of runoff from the area. And then downstream there are channel restorations of the impoundment. So all of those things are a part of this project. And you can kind of see the project area here, the boundary of it. The boundary of that project area here, and you can see the areas that have been buffered and the impoundment dike along here and so forth. And then downstream, let's say over here, are those channel restorations. Now, channel restorations are kind of interesting because we included in the construction of that channel restoration a 2-stage channel with meanders actually in the channel bottom, and you can see the meanders here that were being built. This is pre-construction, after construction, or during construction. Really, kind of looks like a mess, but those have lasted. Those meanders in that stream, and when it's running, you know, at a low level, And then when it gets up higher, you've got this second stage. It's more protected by vegetation here. And today it looks like what you see here in this aerial photo. Another project I want to mention, this is a project that really offers flood protection for downstream areas, but it also offers massive natural resource benefits. It's called the Manston Slough Project. This is a project that has many partners, including the DNR, the U.S. Fish and Wildlife, Bowser, and NRCS, and very importantly, the Outdoor Heritage Fund. The goal of this project is to restore the natural hydrology of a large partially drained wetland in northern Wilkin County, which will provide some floodwater retention and lots of habitat. As it is now in this area, over 50% of the historic wetland basin is dry. The project will restore over 1,800 acres of wetland habitat, which is adjacent to other protected areas, making this a very large continuous block then of natural habitat when it is restored. While the project provides some water retention, you know, there are a lot of other benefits that the DNR and U.S. Fish and Wildlife get out of this as well, and one of them is being able to control the water level in the pools. But the message I've got for you is that LIDAR data was extremely helpful in the development of this project, and it continues to be extremely helpful as we meet with landowners to get the necessary easements, flowage easements that we have to have. And we can take this DEM, you know, a picture of it, go right to the landowner and show them the contours, and we can show them very, very accurately where the water will be when it is at its highest in this project and what the impacts will be to them and what we're offering them for that, for letting us do that. Another project that's in the planning stage, and you're going to hear a little bit more about this, I think, this afternoon, but it's the upper south branch of the Buffalo River. Now, this is an area where there are common breakouts in some tributaries coming into the Buffalo River. There are common breakouts in those tributaries, and the breakouts go across the adjacent farmland. They cause a lot of erosion, damage in the farmland. You know, the area is quite flat. If you know the Red River Valley, you know what I mean. A gopher mound can back up water for, you know, 3 city blocks. So it's really, really quite flat. So when the river breaks out, it just meanders across this farmland and across, you know, the cultivated areas, causing a lot of erosion damage. And that, in turn, of course, leads to water quality problems. So to alleviate the problems, we're looking at setback levees on the river, in places anyway, to prevent these breakouts. But a caveat of this is, while we put those setbacks in, we can't raise or we can't increase the flow downstream of this site. There are people down here saying, "Oh, we don't want more water." So we have to maintain the same flow or even less if we can. Well, this can't be accomplished without some storage, which is something we want to do anyway. So we're examining the potential of some off-storage sites, and you see some of these here shown, some of these areas that we're looking at right now as off-storage. The one that seems to provide the most value to us in this is the one that's labeled 2A. I'll show you here. We'll go back just a moment. It's up in the kind of the northern part of that project area that you saw there. But go back once more. Oh, there we go. I was on the wrong one. It's up here a little higher in this area. Up in here is the one that we're looking at, this is just a closer view of it. The same area without anything drawn on it. This is just the actual showing the DEM. If you look, the reason that area is chosen, the reason these engineers that are looking at this you see how the lines, here the contour lines are kind of close together, so there's sort of a ridge here, and then there's another ridge over in here a little bit. So if we can bring water into here, and here's a water source here, here's another one down here, these ditches coming into here, that we can run into this area and put the water here to store. And we have to enhance that a little bit. We can put some dikes up along here to increase this ridge a little bit, and now we've got a natural pool area in here in order to store water. Well, DEM makes it possible to go to the area and look at the area and see what is going to be the best place that we can put this. So these are examples that we've been working with, and common to all of these examples is the great value that is provided by LIDAR products. Having a DEM allows one to do so much without spending time and money in early field investigations. You saw some numbers dollars that Dr. Mullock referred to in savings. So you go out to these areas, or when you look at these areas on your map and your DEM, you can find or place the footprint of the project, and you can determine the contributing area of this runoff, and with some calculations you can determine how much storage you're going to have. That in turn tells you how high the dike has got to be, and there can even be calculations in of how much this is going to cost, at least some pretty darn good estimates of how much that's going to cost. So all of this now, you can just do it from the office. It saves literally tens of thousands of dollars over the year for us when we were looking at these projects. So it's been, having this available has really been great for our project teams, because several options can be brought forward and can be examined. And you have a good deal of information before you, comparing costs and natural resource benefits that you might derive from that project. So this tool, along with the great partners that we have, partners that watershed districts and SWCDs, and I consider SWCDs to be a great partner for us, but at any rate, they help bring these things forward. And the partners, I'm talking about Bowser with its RIM program, NRCS with its WRP program. I've mentioned how we've used that. They provide the necessary components to successfully plan and evaluate and finish these projects with our LIDAR data. Really very helpful. One last tool I want to mention really quickly is I want to highlight this being developed right now by the International Water Institute and Henry Van Amburg with the MCEA. It is called the Project Planning Tool. Henry, by the way, is here. There are some posters back there that highlight this project. I'd ask you to look at that. Henry, where are you at? Stand up. There he is. Wave your arms. You won't miss Henry. He'll be around to help that out. But this tool right now is only available for the Red River Valley that they're developing, but it could be adapted to other areas of the state. But it just shows the remarkable capability of using LIDAR data to make value-added tools that can be a huge help in identifying and evaluating potential sites. And it goes a good deal further than just having a DEM. So far, they've been testing this. I'm going backwards. So far, they've been testing this on 2 pilot areas, Moccasin Creek, Minnesota, North Branch of the Park River in North Dakota. And what this tool does is recognize where there are opportunities to store water. It then allows areas to be prioritized by effectiveness, and that tool then can be used to evaluate permit complexity being based on streams, wetlands, and biodiversity. And it might even be possible to include land ownership into the permit complexity eventually. Now, all of this is being put into a web application for broad availability. The plan is for water managers to be able to go to this site and start planning a project. That's rrbdin.org. Again, you can go to that site and you can examine the alternatives right from the get-go. So it saves a huge, or it will save a huge amount of time and money. Well, I hope I've whetted your appetite a little bit. They're ready to pull me off the stage here. If you haven't used LiDAR tools, do it. You're going to be amazed at what it can do for you right from your computer at your desk. I know that sometimes you feel like life is like this, but with LiDAR, believe you me, it changes all that. Okay? Thank you.